Hi guys, this video today is going to talk about the linearizing example that comes from the linearizing worksheet. I misspelled linearizing there, there's no L. But this question is actually an old FRQ from an AP test. It's 2006 and it's Mechanics B, I believe is what that stands for, and then question B1. But anyway, I'm going to go through this and explain some things in terms of linearizing, in terms of what this might mean on an AP test. So first of all, we want to read through the question. A student wishing to determine experimentally the acceleration g due to gravity has an apparatus that holds a small steel sphere above a recording plate as shown above. When the sphere is released, a timer automatically begins recording the time of fall. The timer automatically stops when the sphere strikes the recording plate. The student measures the time of fall for different values of distance d shown above and records the data in the table below. These data points are also plotted on the graph. Okay, so first of all, you need to make sense of the paragraph and how that relates to this diagram. So this person has something here that they are using as like a kind of like a measuring. When you measure yourself how tall you are, you put something above yourself, right? So they've got this sphere and it's up against this, so they know exactly the distance. They can measure that. Notice this little height does have a difference there because of the sphere that is there. And so they have this ball, they know the height of the ball, and they have this recording plate, maybe a little bit like the motion detectors that we have. And they've got it set up where it's going to record the data. So as soon as they drop that ball, this motion detector is going to start sensing the position of it. It also says in the writing that then they change this distance. So whatever this distance is the top of the table here, but then they raise it up and they raise it up and they raise it up and so forth. Okay, so once you've made sense of the reading, once you understand the diagram, now let's take a look at the table. This table, in my opinion, is messed up because let's look at the table. We can see that as they increase the height, they're calling it D, but really it's a height, right? As they increase the height, the time is also getting greater. Makes sense. Here's the messed up part. When they go to their graph and they change their table into a graph, the distance is on the y-axis, the time is on the x-axis. That's why I think it's messed up. I just don't like how they've set it up, but we'll get over it. But my point is make sure you're looking and understanding so you know what is on the x-axis, what is on the y-axis, because that's going to be extremely important in understanding the whole big picture. I'm presenting this problem in context of maybe a QQT, a qualitative quantitative response. And this year in 2020, the AP has decided that they are not going to have you making any graphs or diagrams. However, what I can see them doing is presenting this information and then also presenting this information, but maybe already filled in, and you have to explain it. Because that's the essence of a QQT, a qualitative quantitative response, is being able to look at something quantitative and then writing about it qualitatively. And so that's why I want to make sure we go over this problem. Okay, the first part of the problem is really easy, I think. It says, on the grid above, sketch the smooth curve that best represents the student data. Let me show you what you should not do. This is not going to be a straight line. That does not fit. Okay, it's not going to be a straight line. Don't draw a straight line. It even says the smooth curve. So let's make our smooth curve, remembering that usually in science things go back to 0, 0. And so I'm going to draw this smooth curve connecting these points. Not a jig-jag line, just a smooth curve. Okay, I did my best. I'm not great with my marker here, but I did my best. Kind of missed that one. But this is what it is. Now we have to think about back to our linearizing. And if this is the graph that I have, then what is it related to? And we have talked about maybe it is, I'm going to use the letter X. Maybe it's a 1 over X graph, but no, because that would be if it was like this. Maybe it is an exponential, but again, I'm just not thinking that this is going to be exponential. This is actually an x squared, that is a parabola. Okay, this is a part of a parabola, a half of a parabola. So that's what's going on here. We need to convert this over, keeping in mind that this is a parabola. Okay, so that was question A, was to draw our line, which we did, our smooth curve. Now it says the student can use these data for distance d and time t to produce a second graph from which the acceleration due to gravity can be determined. So, question B, if only the variables d and t are used, what quantities should the student graph in order to produce a linear relationship between the two quantities? In other words, how do we change this graph from what it looks like here into a straight line? And so that's where the linearizing comes in. That's where we have to think about how are we going to make this into a straight line. And that's why we were thinking of the square, the parabola. Now let's say that maybe that question about the parabola, when you're on the test, it kind of freaked you out and you didn't really know what to do from there. Then let's think of some other clues. Okay, another clue that we have is this gravity, which we know is measured in meters per second squared. Because the question we're dealing with is, we did decide it was going to be an x squared, but we had to decide, should we square this one or should we square this one? And there's a couple different things you can do, but one thing is we can look at this and decide. And meters per second squared looks like it's the x that needs to be squared, not the y. So we want to change this into seconds squared because we know it's supposed to be meters per second squared. Okay, I'm going to go to my calculator. Get out your graphing calculator and let's enter this data. I'm going to enter this into the x column. I'm going to enter this into the y column. Okay, so if you don't remember how to do that real quick, we're going to go to Stat, Edit, and we will get our tables. If you have old information, clear out the old information by going up to it, hitting clear, and then going back down. Do not hit delete. You will delete the whole column. Don't do that. So we're going to go to L1, clear it, and then fill in the information. Go to L2, clear it, and then fill in this information. So now I have the information that I need from this problem. Now the question is, do I need to square the x or the y? Let me show you a couple of things real quick. First of all, let's just take a peek at the data that we have entered. I'm going to go to Zoom 9 for Zoom Stat. Here's my data. That sure looks like what I have graphed originally, doesn't it? So I'm good on my data. I kind of wanted to do that just to double check my data is in the right spot, but it is. I'm going to go back to my lists now. I'm going to Stat Edit again. On the paper a second ago, we were saying what we really need to square was that bottom row, and the bottom row was the x column. So I'm going to show you in our calculator a little shortcut to do that. If you go over to L3 and go up into the L3 cell, let's say L3 equals L1 squared. To do that, I go over to my calculator, I go to second 1, that's the L1, and then I hit squared, and then I hit enter, and it automatically squares those entries for me. Now you can do a couple things. If for some reason you want to save this L1, I don't know why you would want to do that, but if you would, maybe you could go over to L4, let's say, and say it just equals L1. So now, for whatever reason, I have it here. It is saved. Great. But what I want to do is I want to go back to L1 and I want to put L3 into it now because this is squared, right? So I'm going to go over there, up into the L1 cell, and I'm going to say this equals L3. So second L3. Okay. Now I'm going to go back just because I have to tell you I'm not super proficient with this calculator, but I'm just going to go back and just delete this, clear it actually, hit clear. If you hit delete, the whole thing goes away, so don't do that. But now I have these in L1, L2. I'm going to go back to Zoom Stat and see if this is now a straight line. Zoom Stat. And now I have a straight line. Excellent. I've got it where I want it. If your stuff isn't showing up, remember, you have to turn on your plots. To do that, what I do is I go to y equals, and I go up here to the very top, and I hit enter, and that toggles it on or off. So I need that to be on, and then I come down, and now it's on. The black highlight means it's on, and I have plot 1 and 2 on. And so that's why it's now showing up on my graph. If I want to get an equation for it, which I kind of do, I'm going to go to Stat Calc Linear. So I'm going to go to Stat Calc Linear is 4. And I'm going to enter, enter, enter. And when I get down to the store, I'm going to go to vars, yvars, enter, y1, enter, enter. And I'm going to pause here and I'm going to write these numbers down. So take a second to write these numbers down on your paper. Okay, so I wrote down y equals 4.99x minus 0.016. Remember in physics, we don't have to pay a lot of attention to significant digits, but you don't want to include all of these. That would be a big red flag to the graders saying that you don't know anything at all about significant digits. So I'm just going to say 4.99, and I'm going to say here 0.016. That's what I did, and it is a negative. Okay, so that is the equation of that line, and now if I go to graph, I'm going to go to zoom, stat. Again, actually I can just hit graph at this point because I'm already at the right zoom level. I'm going to hit graph, and it's going to draw that line in for me. And so now I have the line on my calculator. That is helpful because, yeah, I need to match it to what I've got on the paper. Okay, let's transition back over to the paper again. So we have this. We have our equation written down somewhere. I'm just going to write mine up here. Okay, this 4.99 tells me that's the slope of the line that's going to appear down here. So first of all, if only the variables d and t are used, what quantities should the student graph in order to produce a linear relationship between the two quantities? And so to answer that question, we should say that we should graph, okay, so I'm going to write that we should graph d on the y-axis and d squared on the x-axis. Now I'm ready to start to set up my graph. I'm going to put d over here, and that is measured in meters. I'm getting that information off of the table up above. Over here, I'm going to graph t squared, which is measured in seconds squared, and that's my new one. So this axis can be exactly the same as it was before. So I'm just going to copy what they had over here. They were counting by 0.5s on their major axes. Because question C is going to ask us to plot the points. So that's what we're doing now. So we are plotting these points, 0.5, 1.0, etc. Going the other way, if we look back at our data for a second, and to get there, I'm going to go to Stat Edit to find my data. I made my y's. My y's need to go up to 2. I did that already. My x's, look how small these decimals are. That's okay. I need to get up to 0.4. I somehow want my graph to get up to 0.4. Okay? Does not really matter how you count. Just make them reasonable. So make 0.4 like the end and work back from there. And again, however you want to set these up doesn't matter. One time when I did it, I counted by 0.05, or excuse me, yeah, that 0.05 and then 0.10, 0.15, etc. Another time when I did it, I decided to make them a little bit bigger increments or smaller, depending on how you say it, 0.03, 0.06. And another way is this was an answer key that I actually got online. This person is counting by 0.1 every 3 boxes. So this is 0.1 and then 3 more boxes, 0.2 and then 0.3, etc. up to 0.4 and so forth. So again, however you want to do it, I kind of like her increments. That just kind of makes sense to me. So actually, I'm going to go with that. All right, so I've got 0.1, 0.2, 0.3, 0.4. Now I need to plot my points from my new table, which we didn't write down up here, but probably a good idea to record another row here. I believe on many of the ones that I've seen from AP, they actually give you another column to do that in. I'm kind of surprised they didn't do that here, but it is an older test, 2006. In the newer tests, I think they would give you an extra column to do that in. But let's just write down what our new numbers are, and these would be our x squared numbers. Okay, so these are the numbers that I came up with for my table. Now, remember, you could have done each of those by hand. You don't have to do it on your calculator through the list like I did. I just think that saves a little bit of time if you know how to do it. So we've got these set up. So those are the points that we need to start plotting. Okay, so my points are going to look something like this. Again, I could look at my calculator to get an idea a little more clearly of exactly what they are. I'm going to use a straight edge, and I'm going to connect these with a straight edge. And again, on the AP test, probably what we're doing now, if this was a question on the AP test for 2020, then this would already be done and you would just have to interpret it. And maybe something like they would take off these units and you'd have to decide what these units were, something like that. But I'm going to connect this with a straight line. Okay, so I have something like this. And again, I know that this is the equation that goes with that straight line, so I'm going to maybe have that right there for me. Okay, now is going to be the part where you're going to have to do some interpreting of this. This is where your qualitative, quantitative comes in. Because it says to plot the points, we did that, and sketch the best, okay, we did that. This, again, all of this probably would not be on the AP 2020 because of the way it's set up. But the next parts would kind of depend on that. So maybe this is already filled in, this is already filled in, maybe they're missing their units, you have to interpret it, and now we're going to go on to part D. Using the slope of your graph in part C, calculate the acceleration g due to gravity in this experiment. Okay, we know that the slope of this line is 4.99. I'm even going to just, well, I'm going to leave it 4.99. Another one, the answer keys I looked at said 5, but I'm going to leave mine 4.99 for now. So that's the slope. Even if you had not done this on your calculator in the table, what you could do to find this slope is to take the rise over run. The rise being 2.0, the run being 0.3969. And when I did it that way, I got a slope of 5.039. So it's about 5, right? Whether we did it this way or this way, we got about 5. So we're okay with that. I think either one of those is fine. Our calculations are going to be good with either one of those numbers. Okay, so that's our slope. But that is not gravity, right? It's not even close to gravity, actually. It's half of gravity. So what do we have to do from here? From here, we have to think about what all is going into this whole experiment. So when they were doing this, what all went into that drop? Well, that's a drop. It's gravity. It's a change in height. And we have to go back to our kinematic equations and remember what are some of those kinematic equations. So I just want to take a minute to look at some of these kinematic equations and decide which one to use. The one that I'm going to use is going to be this one, basically. Now, this was also the one where we said if some of these things are 0, those parts can drop off, right? So one thing is we want to think about, this is all in the y direction, right? So this is in the y direction, It says Vx, we actually want that to be the y direction. All of these things, Ax is actually the y direction. All these things we want to be in the y direction. We're looking for x in the y direction. The initial x was 0. The initial velocity was 0. And so then we have this equation that just says the x in the y direction is 1/2 at squared. And that is, when we were back in the kinematic unit, that was kind of a little shortcut that we would take from time to time because that happens so frequently. I'm going to take this 1/2 at squared and use it on that problem. So I'm going to use this y equals 1/2 at squared in conjunction with this equation, this line. So I'm going to compare this line basically to y equals mx plus b. Well, one thing is there's no plus b on this, so this isn't really going to have a b, which is fine because look how small my b is. It's practically 0, right? So that's fine. That's gone. My x is my t squared. That's my x. My m then is 1/2 a. Let me get back to that x being t squared. Look at our graph. Here's our x-axis. What's on our x-axis? T squared. So that x is t squared. That's where that came in. The m is whatever's in front of that. And so for this case, it's 1/2 a. Okay, let's get back to that slope for just a second. We can use 4.99. We can use 5.04. We can use 5.0. That'd be okay. So I'm going to now say I figured my slope to be 4.99, and that's supposed to be equal to 1/2 a, right? As far as the equations go, this 4.99 corresponds with this 1/2 a. And so if I multiply both sides by 2, again, depending on how you rounded this, but if you take 4.99 times 2, you would get 9.98. And we probably want to say that is in meters per second squared, because look, this is also meters per second squared. So using the slope of the graph in part C, calculate the acceleration due to gravity in this experiment. Gravity is 9.98 meters per second squared. If this were a qualitative quantitative question, you'd have to do some explaining. And so maybe, like I said, maybe these lines are already drawn in here, these lines are already drawn in here, and you have to explain that to get this linearized, you had to square the x value, and that created a straight line. Then you would also have to explain something about that the slope of this line is 4.9, and then you'd have to explain that how that corresponds to the kinematic equation, and so that gives you the gravity of 9.98. In other words, you wouldn't only have to find the gravity, you would have to explain the gravity. And getting back to, trying to second guess on what the College Board is going to put on this test, I don't know. But maybe they have this graph already filled in, they have this table already given to you, they have this graph, you have to decide where they come up with this graph. Maybe then they say, they decided that the gravity was this. How did they come up with that gravity? And so you would have to talk about, this is the slope of the line, this is the kinematic equation, and so they solved that by setting those equal to each other. Something like that. You just would not have to only do the math, but also explain it. That's the essence of qualitative quantitative. Now, the last part on this test says, state one way in which the student could improve the accuracy of the results in the experiment were to be performed again. Explain why this would improve the accuracy. So, you just would have to find one thing that you could say that might improve the accuracy. Some things that I could think of, you could say you could do more distances or make the distances greater, because the greater this distance is, the more accurate it's going to be, the less room for mistakes, right? Because like, I'm going to draw a bigger line for my D. If you had like, let's just say, a 0.01 second mistake in here, that's a pretty big percentage. But if you only had a 0.01% or a second mistake in here, it's not as big of a percentage, right? So one thing you could say for improving the accuracy would be, instead of taking these distances, maybe take larger distances, 0.5, 2, 0.5, 1, 2, and 4, something like that. I don't know, just picking some larger distances so that you have less percent error. You could also talk about maybe you did more than one trial and you averaged those trials, and when you did that, you had a better idea on that time. That would be one way to do it. If there was any way to improve the level of accuracy on the decimals, that might be something that you could do. So as long as you improve, the question just asks for one way. So I think that, like I said, if you could increase the distance D. So here are some options. Increase the distance D. This would decrease the percent error, have several trials at each distance and then average them, have more than 5 distances. There's a variety of things you can do, but it only asks for one. So just have one on there is all you would need. Okay, again, my intent of this video was to show you how this linearizing might play out this year. Is it going to be on a test? I have no idea. There will be a qualitative quantitative. Qualitative quantitative requires that you look at quantitative data and you make some sentences about it. And that's what they're doing this year, is they are asking you to write sentences, not asking you to make graphs, but asking you to make sense of those graphs. And so I thought this was an important concept for us to cover.